Welcome to the Daily Space Weather. We've seen an M-class flare in the past about 8 hours. From this sunspot up here, I think it's 2920 is the name of that one. We've got a large sunspot right in the Earth-facing zone, just moving past the center line of the Earth-facing portion of the solar disk. That's 2916, still capable of producing major flares. Here's a close-up. And we'll show an extreme close-up at the end of the video. Here at the Smash News Network, least busted name in news. Let's get to lots more data on the daily space weather, and congratulations on realizing that the channel exists. Here's that same view. This is 171 and 193 angstroms composite. You can see some coronal holes there south of those sunspots. Here's a close-up. That does include an M-class flare. Here's a colorized magnetogram. Again, you can see how large that sunspot 2916 indeed is. It's got multiple umbrae there that are the size of the Earth or larger. Solar flare warning continues. We would have seen some radio blackouts associated with that M-class flare. Again, that was from this sunspot up here. And a newly formed active region up here as well. I think that's 2921. Here's the full disk in ionized helium. And there was no coronal mass ejection associated with this M-class flare. The plasma appears to have collapsed back down onto the solar disk, onto the chromosphere, or the lower corona, or something like that. You can see right there, you can see some of that filamentary, you can see like a brightening as that appears to collapse back down to certainly the lower corona or upper chromosphere. The radio flux has come down a bit, and we've seen the sunspot number dip as well. And it is currently at, I think it's 125. This is the 1-year chart from Solon.info. The black line is the radio flux, the red line is the sunspot number. 124 solar flux units is the current radio flux, the most proportional data set to sunspot number when we're looking at things like solar activity, solar cycles, etc. There is a forecast for a minor geomagnetic unrest period early in the day tomorrow, between 3 and 6 Universal Time on December 29th. And we do see a coronal hole wind stream currently striking. Let's take a look at global seismicity. There were some earthquakes in South Carolina. At least 2 of them. One was like a 3.3. And let us know in the comments if you felt that quake, or if you felt a quake, period, or if you've never commented on our videos before. So no major quakes. It's actually a lull in earthquake activity, and we actually see an uptick in volcanic activity. How about this 4.5 in Stanton, Texas? Leave us a comment if you felt that one. All of our Texan viewers, that's in West Texas. Looks like barely any earthquakes even over a 5 magnitude. Did we even see a single 5 magnitude quake over the past 24? No quakes over a 5 magnitude in the past 24 hours, folks. That's a serious seismic downtick. And we see a serious volcanic uptick. Let's check the list here at volcanodiscovery.com. Fagradalsfjall may be fixing to do another pretty epic eruption here, as thousands of earthquakes have been detected, mostly with magnitudes of 4 or more since the solstice. So we'll see if Fagradalsfjall begins erupting. Shivaluch, volcanic ash not identifiable in satellite imagery. It doesn't mean it's not erupting. That's located on the Kamchatka Peninsula. A, shall we say, desolate location. Mount Merapi has a lava dome that may collapse. It's about 1.6 million cubic meters. And there's actually an image of that right here. Huge lava dome there at Mount Merapi. Continuing down the list here, we've also got... Oh, and by the way, that could collapse and cause massive pyroclastic flows. Please don't be in the region below that lava dome near Mount Merapi, which is located, by the way, in Central Java, the Isle of Central Java, Indonesia. On East Java, Semeru is erupting in an explosive fashion. Flight level 130, it's a 13,000-foot ash plume. Mount Yasur, low-level eruption at Mount Yasur on Vanuatu's Tanna Island. Aoba, also on Vanuatu, has raised the alert level to level 2. A new cone has formed within the Voi Lake, within the Voi Lake, characterized by near-constant emissions of steam and ash generating wet tephra ejecting above the lake. Tephra is volcanic rock that comes out of the water. Please avoid the summit area of about 2 kilometers radius, an area of flowing creeks during torrential rains, and rains can cause phreatic eruptions. Kilauea has ceased its lava effusion, so the creation of new geography, new territory over there in Hawaii has ceased for a while. We'll keep an eye on that. Hunga Tonga Hunga Ha'apai continues to explode, producing a 12,000-foot ash plume. Hunga Tonga Hunga Ha'apai, located on the Isle of Tonga. Fuego in Guatemala, mild explosive activity there. No indication of the volcanic ash size. Nevado del Ruiz exploding, flight level 200. It's a 20,000-foot ash plume. Nevado del Ruiz located in Colombia. 2 Ecuadorian volcanoes on the list here. Sangay producing a 20,000-foot ash plume. Revenador producing a 15,000-foot ash plume. Down to Peru, Sabancaya is exploding. 24,000-foot ash plume. Nevados de Chilean, volcanic ash not detected over central Chile from Nevados de Chilean. And Piton de la Fournaise on the Isle of Réunion. No significant change in activity. Small lava fountains coming from Piton de la Fournaise. And some lava flows advancing only a small distance on the Isle of Réunion. Remember, folks, do not pole vault the caldera. You're all invited to visit the links below the video, such as smashamash.com/smashteam. There's a teaser. We'll continue putting up publicly visible and free posts through the old year, thanks to our paid subscribers at the gold, silver, and the gold, silver, and gold annual paid-up subscription levels. Welcome to the Neo Renaissance. You can find links on our homepage to the merch. Today's featured product is the Do Not Pole Vault the Caldera socks. Smash staff and I have them, and they're quite comfy. The snappy graphics here are available on lots of different products, like tote bags and tapestries and throw pillows and phone cases, and you can even get things like stickers and t-shirts. You can even get a Do Not Pole Vault the Caldera mini skirt or leggings. The bright red and blue colors on this will go with various items in your wardrobe. Tell your friends and foes about the channel. Please press like, subscribe, etc. if you're not willing to financially support the channel in any way, or perhaps you're unable. In any case, do not pole vault the caldera. Do support the channel, become a member of the Smash team, pick up some merch. Click the links below the video. Perhaps purchase a bicycle if you don't own one or you need to upgrade yours or whatever. If you're looking for apparel or other accessories, new parts, maybe you need a new fork like that Marzocchi Z3 Atom Bomb. Actually, I think it's a Z2 Atom Bomb Race on my mountain bike. Hit me up. You can find links below the video. Curated.com/e/Dan.Nigro is the link, and you can find links below the video to that. Let's get back to space weather data. The GOES magnetometer over the past 3 days. A little bit spiky. There has been a coronal hole wind stream striking Earth. We'll get to it. First, the top view ecliptic plane field plot showing the polarity of the heliospheric current sheet. The plasma that the sun blasts out is aligned to one pole or the other. Earth is currently in a plasma sheet aligned to the solar north polar field. That's why it's showing up here in green. The south pole oriented current sheet shows up here in red. We expect Earth to remain in a north pole current sheet for the foreseeable future. Here's a line of sight plot. Shows you the solar magnetogram, basically the same data except for the magnetogram. Lots of sunspots facing Earth and now some coronal holes as well. They're all North Pole-oriented ones. South Solar Polar region remaining sort of... It looks like it's actually split here as the solar polar field reversal process occurs. This also shows you the solar B field in blue lines. Those are the potential surface source, the potential field surface source lines of the sun's B field. The field going through the magnet will show you the Earth's B field momentarily. First, the 193 angstroms view from the Solar Dynamics Observatory. You can see some of those coronal holes there. Near the equatorial area, we can expect some additional high-speed wind streams from those in a few days. Next, we'll look at sunspots. This is 1700 angstroms. And check out the size of these sunspots down here. That's quite a big sunspot group. That's 2916. The M-class flare came from this group up here. And we've got 5 or 6 named sunspot groups at the moment. Only one of those is not capable of producing major flares. That's this one. All the rest are capable of producing C or M or even X-class flares when it comes to 2916, I would say. And if it does so there, the likelihood of Earth-directed coronal mass ejection is very high. Solar flare warning in effect, coronal mass ejection warning remains in effect until further notice. So here's this M-class flare. The peak flux was right around 4 o'clock. Universal time today on the 28th. There was also a high-class C flare that occurred about 3.5 hours later there. That's the GOES X-ray flux over the past 3 days. Let's bring up the one-day chart real quick here just to see a better resolution there of those most recent flares. Things looking like they're calming down. That doesn't change the fact that there's a solar flare and coronal mass ejection warning in place. No relativistic particles have struck as a result of that M-class flare we saw this morning. Let's get to the real-time solar wind. And you can see the signature right here at the end of the graph. This is the signature of a coronal hole wind stream, folks. You can see the density dropping off while the velocity increased. So I basically had to guess that yesterday. Shout out to Brett. Thanks for leaving a comment about whether or not it's a CME or a coronal hole wind stream. We appreciate comments like that. I like to be challenged because if I'm wrong, I've probably learned something. What I don't do when I'm wrong is double down and try to gaslight people on the internet and make a fool of myself. When you're incorrect about something, folks, that's usually a good thing, especially if you're already an expert. It means you've learned something. Current conditions are solar wind density still elevated here at about 12 protons per cubic centimeter. Solar wind speed elevated as well, 532 kilometers per second. The BZ has just shifted into negative territory, so that could cause a little bit of an uptick in geomagnetic activity. We'll see current conditions are only a KP of 2 geomagnetic calm conditions. The KP index is a measurement of global geomagnetism. Each bar here represents 3 hours. Next, Earth's geomagnetic moment from space. And you can see some variations here. Magnetohydrodynamic pressure is the scale that we're showing here. It's nanopascals. And some oddities there. These could be caused by errors in the model, folks. If you refer back to the real-time solar wind, you can see a bunch of error bars down there at the bottom. So some of that data might not be correct. Typically, coronal hole wind streams are not that pulsatile, I guess I'll say. Anyway, here's Earth's magnetic moment from the ground. Ground magnetic perturbations in nanotesla magnetic flux density. And we do see some magnetic pulses coming out of places like the Indian Ocean here. A little bit of elevated perturbations to Earth's B field caused by that incoming coronal hole high-speed stream. Next, a diagram of the solar system. Here is where things are now. We'll advance this 1 week. Not 8 days, 1 week. There's where things will be in 1 week. In the new year, on January 4th, Venus and Earth will be at opposition, conjunction, whatever it's called. They'll be in line with the sun, and the moon will be there too. That should frighten people, although it's not going to kill you or anything like that. Next, if you're up before dawn, you may see Mars rising ahead of the sun. This is the star chart for what's going on over the Lehigh Valley. as Cygnus circles Polaris. Yeah. Cygnus. Did you know that Deneb is the celestial pole star at the other end of the precessional axial Earth wobble tilt cycle? Yeah, Deneb. It's the most intrinsically bright object visible from our solar system. It's just a high-mass X-ray binary / Wolf-Rayet star, and one of the only known, if not the only known, cosmic ray point source. Let's continue on to look at our coronal mass ejection warning. So you've got the stereo A coronagraph here, located at Lagrange point 5 on the left, the LASCO C3 located here on the right, which is at Lagrange point 1. No coronal mass ejections were generated by or associated with that M-class or C-class solar flare that we just saw. That plasma looks like it's collapsed. Again, stereo A located at Lagrange point 5, and the SOHO-LASCO C3 located here at Lagrange point 1 between Earth and Sun. Today's cosmology segment's got to be brief, and it's showing a 4-year-old sun halo over Sweden. This is caused by the prismatic effects of ice crystals in the atmosphere, and just great imagery there from 2017 at Vamalden Ski Resort in Sweden. Spectacular. And when it gets very cold, these things become more likely to happen because of hexagonally shaped ice crystals aligning in fairly consistent patterns due to, like, I guess I'll say, homogeneity in the atmosphere. Don't forget to check our other cosmology segments as well, folks. We've got over 200 of them on our playlists. Here at the Smash News Network, least busted name in news, we're quite interested in cosmology subjects as it is an emerging and legit branch of science. It's getting weirder and weirder, and that we like. Again, check the playlists at youtube.com/smashamash/playlists. If you're watching the videos any place besides on YouTube, consider watching them on YouTube and checking our other videos. There are all kinds of additional content besides space weather and meteorology videos. Next, charging hazards. We don't see any at the moment. We see quite a chaotic electron flux, though. Here's the 1-year chart of the relativistic electrons surrounding Earth in the lower Van Allen belt. Here is the 3-day chart of the GOES 16 and 17 measurements. And as we forecasted yesterday, you can see this dip in the electron flux. That is associated with, or perhaps a result of, the incoming coronal hole wind stream. I try to keep my physics to a certain series of terms because I don't want to commit physics blasphemy. We make these videos so that they will not cause offense to any of you science nerds out there, including the sticklers. Anyway, that was a forecasted dip in the electron flux. You can see yesterday's daily space weather video if you don't believe me. Here's the relativistic electron forecast model, and you can see a continued downtick is expected. I would tend to agree there's going to be additional coronal hole wind streams on the way. Next, the total electron content forecast, showing the total electron content between your GPS satellite and your handset, and we can expect massive errors here over North America, the Pacific Ocean, any place you see red on this imagery. Very chaotic electron flux at the moment here. And we typically see less organized electron contents during coronal hole wind streams, and certainly we do. So lots of chaos happening, likely GPS errors all over the place. Have your Wi-Fi accuracy turned on to reduce those GPS errors. Next, your ionospheric animation. The F ionosphere layer is located at about 300 kilometers of altitude. That's, by the way, where the GOES 16 and 17 are endeavoring to measure the electron flux, at the F ionosphere layer. And here's a visualization of the F ionosphere layer in megahertz. Millions of vibrations per second, and you can expect to see huge anomalies here. Huge high-frequency anomalies there in the Southern Ocean. Also low-frequency anomalies over places like northern South America. And And we'll let it play through. We'll bring up the latest image and we'll show you the Anomalygram before we do a bonus features. So here's the Anomalygram, showing you anomaly in megahertz from the 30-day median, and quite a lot of anomalies here, both of the high and low frequency variety. You can see wild swings here, swinging from high to low frequency. That's a 6 megahertz swing if you see it go from red to dark blue. Quite a bit of anomalies at the moment. A lot of low frequency anomalies in the southern hemisphere despite it being summertime down there. So anyway, here's the latest image. That's 1345 universal time ionogram, and there's 1345 universal time anomalygram. Here come bonus features. Bonus feature number 1 is the ground-based solar observatory at Cerro Tololo, Spain. Cerro Tololo, Chile, rather, not Spain. And there's a bunch of missing data on there. We won't really worry about it. We'll continue on to show you the NASA GOES 16 SUVI imagery. This is a little more current. We'll zoom out to 67%. There we go. Again, solar flare and coronal mass ejection warnings are in place, folks. We've got a situation here that could create some serious geomagnetic events. Next, your latest intensitygram and your latest magnetogram refreshes. We'll do a little tour. That's capable of producing major flares. That's a beta class sunspot. This is just a huge sunspot. I would note also that we're getting these crescent shape structures here in the umbrae, the trailing umbrae, on sunspot 2916. We've also got some sunspots at different latitudes here, and we've been seeing this throughout solar cycle 25. Sunspots at higher and lower latitudes with relation to each other. Typically the sunspots migrate throughout the cycle and get closer to the equator as the cycle progresses. We've been seeing some high and low latitude sunspots at perhaps some unexpected locations. So this one up here, quite large actually. Those umbrae are about the size of the Earth as well. The M-class flare came from this area right here. And we'll show you the magnetic fields as well. Let's go backwards. So there's that new sunspot group. That's capable of producing major flares. Don't be surprised to see an M-class flare come from that one. And here are the rest of the fields. We'll just go around the horn here to show you high-res close-ups. That's a beta-class sunspot group. That's just a gigantic sunspot group. Just spectacular. And that one's not quite as rowdy. We'll close out with the extreme close-up here. This is 131 and 94 angstroms from the Solar Dynamics Observatory. Two of the best wavelengths to show solar flares. They take 10 images per minute instead of only 2. And we'll close out today's video with 335 angstroms, the full disk view. Thanks again, everybody, for tuning in. Congratulations on realizing the channel exists, and may that solar wind be at your back. Opinions expressed in this video, not necessarily the opinions of Smash News Network, least busted. Name and news.